All right, honors geometry. This is Mr. Larrabee, and I'm going to go over the three questions that we didn't get much time at all to talk about today during class. And the first one has to do with obtuse angles. Briefly, in the Desmos today, you guys sorted right angles, obtuse, acute, and straight angles. It clearly looks like you understand what that is. But as far as how it applies to an algebraic question where you have to solve for something, this is how it works. So here we know that we have an obtuse angle called angle A. And this M here stands for measure. So like the size of the angle, is it 40 degrees? Is it 90 degrees? Is it 60 degrees? That's what it stands for, measure. Angle A by itself is just the name of the angle. So if it's an obtuse angle and you're trying to find out what value of x always guarantees me that the measure of angle A will be between certain values. If it's obtuse, that means that I know the measure of my angle will be between 180 degrees and 90. So greater than 90 and less than 180. This is called a compound inequality. And this is the measure of angle A. So because I know the expression for measure of angle A is 2x minus 6, this allows me now to solve this compound inequality. You can do it in two steps. You could cover up the 90 and just work with the right side where it's less than 180. Then you could do a separate one where you're covering up 180 and then having it greater than 90 and put those two together. But you could also make it a compound, meaning more than one inequality at a time. So I'm going to add 6, just undoing my operations. We're left with 2x less than 186 and greater than 96. And then we're going to divide by 2 to everything. Now, one thing to keep in mind is if this were a negative 2, when you multiply or divide by a negative with inequalities, that's always going to flip the sign. So in this case, we don't have to worry about it. We're lucky. So x has to be between 143 and 48. So x is greater than 148 or greater than 48 and less than 143. So any value you plug in between those two numbers into the expression for the measure of angle A will give you an angle that is obtuse. For the next question, and by the way, as I'm doing this video, I hope also at home in your notes that are dated for today, which is September 10th, you are taking notes and writing all this stuff down. Okay, so here we have points A, B, and C. They are collinear, meaning on the same line. On the same line. Where B is located between A and C. And then we have these expressions that give us the distances of certain segments. So making a quick diagram, I know we have 3 points. I know that one point is between the other. That point being B. B is between the other 2 points. So let's say it's A, C, A, and C, A, B, C. Okay, so what we do know is that this length from A to C is x squared plus 2x plus 40. AB is 15 plus x, and BC is minus x plus 40. Notice something. For all of these segments, there is nothing written above the letters. So something to distinguish here. If I were to say AC, this is the name of the segment. If I were just to write AC with nothing above it, this means the distance from point A to point C. They mean two different things. Okay, so it's actually a measurement. Whereas if I were to write the segment above it, that means that I'm naming the segment. So looking at my diagram, we have a relationship where if I were to add together AB and BC, it will be the same distance as A to C. So that's the setup I'm going to have. If you want to solve for x and be able to substitute it back into these expressions, you need to have an equation to solve. So in doing so, we're going to be able to say 15 plus x plus a negative x plus 40 is going to equal x squared plus 2x plus 40. All right, doing some simplifying. The x's on the left side will cancel out, and I have 55. Nothing to combine on my right side. And to solve quadratics, the main method we are going to use to solve quadratics is going to be factoring. Please do not get comfortable or think that I'm going to be looking for anyone to use the quadratic formula, because I will not be. Use it to check if you want, but I need you to be able to factor. So I'm going to set my quadratic equation equal to 0, because the idea is that we are going to use the zero product property, and that only happens when it's equal to 0. So I will have 0 equals x squared plus 2x minus 15. So I'm going to use the factoring method to rewrite this quadratic in standard form into factored form. That way I have a product of two numbers equal to 0, and the only way that can happen is if the first product is equal to 0 and or the second one is equal to 0. And that's where I'll find my solutions. In this case, we'd have x and plus 5 and minus 3. So solving each one of these factors separately, x plus 5 equal to 0, that means x has to equal minus 5. X minus 3 equals 0, well, that means x has to equal 3. So there's my two solutions. But now the question is asking, solve for all lengths of BC. Well, BC is negative x plus 40. So BC, the distance from B to C, is negative x plus 40. So two different answers we have here. Negative minus 5 plus 40 and negative 3 plus 40. In the top case, this will become a positive, so we'll have a distance of 45. In the bottom case, this will be 37. So those are my two distances from point B to point C. On the next question, we have the word trisected. Okay, trisected means to split into three congruent parts. Okay, so ABC is trisected. So this would be ABC is the largest angle. Measure of, right, remember M means measure, angle DBC. Okay, so D to B to C is 5x plus 5. So I'm going to just annotate as I go. This angle right here is 5x plus 5. And the measure of angle ABD, that's going to be this angle. I'm going to be able to say that this angle is 4x minus 11. Now the key here is that ABC is trisected, meaning it's split into three congruent parts. That means that I'm going to have three congruent angles. They're all the same. So our relationship here would be one of the 4x minus 11s would equal half of one of the 5x plus 5s. Or you could look at it another way. If I were to take 2 of the 4x minus 11s, that will be equal to 1 of the 5x plus 5s. So it's a 1 to 2 ratio. And so we can say 2 times 4x minus 11 is going to be the same as the measure of 5x plus 5. And now we have an equation where we can solve for x and then ultimately determine the measure of angle EBC. So distributing the 2, getting my like terms on the same side. I'm going to do 2 operations at one time. We'll have 3x equals 27. Then you can divide both sides by 3 to get x equal to 9. So in the measure of angle EBC equals EBC. Well, EBC is just one part. That's going to be the same as the measure of angle ABD, which we know to be equal to 4x minus 11. So using that, 4 times 9 minus 11, 4 times 9 is 36, take away 11, you'll have 25 degrees. So that means that this angle is 25 degrees. Furthermore, it means that all 3 of these parts are 25 degrees. That's a synopsis on the 3 questions from class today. I hope that gave you quite a bit of clarity. Please reach out if you have questions. I also have office hours tomorrow from 2 to 2:50, but please email me before you decide to join my Zoom so I know that you are coming. If you don't know how to get to my office hours, if you need help, email me, let me know, and we'll send you the link or just tell you how to get there. Take care. See you soon.